So let's talk about how we can solve this problem. So we have a 15 kilogram box and it rests on a horizontal frictionless surface and it's attached to a 5 kilogram box. Now what we need to do is calculate the acceleration of the system. So how can we do so? If you want to try this problem, feel free to pause it and work on the problem yourself, and then unpause it when you want to see the solution. Now, a quick and simple way that I like to do in order to find the acceleration is I like to use Newton's second law. The net force is equal to the mass of the system times the acceleration. So therefore, if you solve for the acceleration is going to be the net force, which you can write it like this if you want to, divided by the total mass of the system. Now, the only force that caused this entire system to move in this direction is basically the weight of this object. Now let's call this M2 and let's call this M1. So the weight of this object is basically mg, but we need to use m2g because mass 2 caused the entire system to fall down. And then you want to divide it by the total mass of the system. That's m1 plus m2. If you increase mass 1, the acceleration of the system decreases. The more inertia that this object has, the more resistance that's going to be present. It's going to be harder to move the mass because there's more inertia, which is the tendency to resist its current state of motion, which is currently at rest. So if you increase m1, the acceleration of the system decreases. If you increase m2, it can increase it up to a maximum, which is 9.8. So this is the equation you need in order to calculate the acceleration. But let's derive that equation by using a process, which will help you to solve other Pulley type problems. And also we got to find the tension force. So let's focus on M1. Our goal is to find the acceleration of the system. Now, the rate at which block 2 moves is the same rate at which block 1 moves. So therefore, the acceleration on block 1 is equal to the acceleration on block 2 because they have to move at the same rate. They're connected by the rope. So for block 1, we just need to focus on the forces in the x direction. The only force that accelerates block 1 to the right is the tension force. So the sum of all forces in the x direction for block 1 is simply equal to the tension force. That's the only force that's acting on that block. And based on Newton's second law, the net force is equal to ma. So this is going to be m1 times a in the x direction. So that's how you can calculate the tension force once you know the acceleration. Now let's focus on block 2. So we need to focus on the forces in the y direction. Block 2 has a downward weight force, which is basically m2g. Remember, weight is just mg. And the tension force slows down the descent of block 2. So the net force in the y direction is the upward tension force. It's going to be positive because it points in the positive y direction, minus the weight force. This is negative because it points in the negative y direction. Now looking at this force, we know we need to replace it with ma based on Newton's second law. Now, is there anything special that we need to do? What we need to do is, well, let me ask you a question. Should we replace this with m2ay or negative m2ay? What would you say? Now, the net force on block 2, it's going in the negative y direction. So therefore, this thing has to be negative. Now, let's say if we were to use positive m2ay. In order for this to be negative, that means ay itself has to be negative, which in fact it is technically. For block 2, because it's moving, it's accelerating downward, the acceleration in the y direction should be negative. However, these two accelerations must be the same in order for this problem to work. And a of x is definitely positive. So we want ay to be positive. At the same time, this has to be negative. So therefore, what we need to do in order to make this work is we need to use this one. Because the acceleration in the y direction, it's going to be positive, which we need it to match the acceleration in the x direction, because we need to connect them. They're supposed to be the same in this problem. And if we use negative m2ay, that will make the net force in the y direction negative, which is it's supposed to be because it's going down. So that's what we're going to have to do. So for these types of problems, if the block is descending, if it's decelerating in the downward direction, use negative m2a for the net force in the y direction. If it's going up, use positive m2a. And I'm going to have other videos that illustrate that example. So make sure you understand that. So this is going to be negative m2ay. And now let's solve for t. So let's take this term and let's add it to the other side. So what we now have is m2g minus m2ay. So now we have two ways in which to calculate the tension force. So what we can do is set m1a equal to this stuff, because they both equal t. So m2g minus m2ay is equal to m1ax. Now, ax is the same as ay, because as mentioned before, this whole system moves with the same acceleration. So we can say what we have is m2g minus m2a, which equals m1a. So now, what I need to do is take this term and move it to this side. So this is going to be m2g is equal to m1a plus m2a. So now I need to factor out the acceleration. So this is going to be m1 plus m2. And solving for a, I need to divide both sides by m1 plus m2. So therefore, I'm going to put it here. The acceleration is m2g divided by m1 plus m2a. Now this is the same equation that I wrote earlier in the video. As you can see, the acceleration is the net force. The net driving force is the weight force that causes it causes the whole system to move to the right and in a downward direction, and then divided by the total mass of the system, m1 plus m2. So now let's go ahead and get the answers. So let's erase a few things. So let's start with the acceleration. So m2 is 5, g is 9.8. m1 is 15, m2 is 5. Now 5 times 9.8 is 49 newtons. 15 plus 5, that's going to be 20. So it's going to be 49 newtons divided by a total mass of 20 kilograms. And so the acceleration of the whole system is 2.45 meters per second squared. Next, we need to calculate the tension in the rope. The easiest way to do that is using this equation, m1a. So it's 15 kilograms times 2.45 meters per second squared. And so the tension force is 36.75 newtons. Now let's make sense of this problem. So the 5 kilogram mass has a downward weight force of 5 times 9.8, which is 49 newtons. Now the 15 kilogram mass is being pulled to the right by a tension force of, I believe it was 36.75 newtons. Now you want to make sure all these numbers make sense. The net force on this mass is basically 15 times 2.45, which is the same as the tension force, because the tension force is the only force acting on the block. Now the tension that pulls the 15 kilogram mass to the right is equal to the same tension force that slows down the descent of this object. So that's going to be 36.75 newtons. Now, the difference between these two forces, you have a force that's pulling it down with 49 newtons, a force that's pulling it up with 36.75 newtons. So the net force in the y direction is the difference between these two objects. So if you take 49 minus 36.75, that's going to give you a net force of 12.25 newtons that acts on the 5 kilogram mass. Now, if you want to check your work, make sure that if you take this and multiply by the acceleration of the system, you get this answer. So if we take the 5 kilogram mass and multiply it by 2.45 meters per second squared, that gives us the net force acting on block 2 on the 5 kilogram mass. So you want to make sure that all of the numbers match up. The tension force acting in the horizontal direction is the same as the tension force in the vertical direction. If all the numbers add up, then you know you did the question correctly. So here's another similar problem, but this time there's friction. A 12 kilogram box rests on a horizontal surface with a coefficient of kinetic friction of 0.25. The 12 kilogram box is attached to an 8 kilogram box through a massless rope. What is the acceleration of the system? So this is the 12 kilogram box and this is the 8 kilogram box. Now, to find the acceleration of the system, at least the fast way, keep in mind it's going to be the net driving force divided by the total mass of the system. Now let's call this M1 and this one M2. So just like before, the driving force of the system, the force that causes the whole system to accelerate towards the right and in a downward direction, that's going to be the weight force, the weight of block 2. So that's M2G. But in this example, that driving force is impeded by friction. So friction is going to act on this block because it's in contact with the horizontal surface. And the kinetic friction is going to slow down the whole system. So we have to subtract the main driving force by the force that slows the whole system down, which is kinetic friction. And then divide it by the total mass, which is M1 plus M2. Now keep in mind, kinetic friction is equal to mu k times the normal force. And the normal force on the horizontal surface is mg, but this is going to be m1g because friction is acting on mass 1. So this is going to be the entire equation that we need in order to calculate the acceleration. So what we're going to do is, just like before, we're going to use a process to derive this equation. But if you have a test and you need to get the answer quickly, that's the equation that you want to use for this example. Now let's start with the forces that are acting on block 1. So we're going to focus on the horizontal forces in the x direction. So we still have a tension force that accelerates it to the right, but it's impeded by friction. So T is in the positive x direction. Kinetic friction is in the negative x direction, so we're going to put a negative sign in front of that. And the net force in the x direction, based on Newton's second law, net force is equal to ma. And Fk is mu k times the normal force, where the normal force is mg, but we need to use m1g. So let's solve for t. So I'm going to take this and move it to the left side. So m1a plus mu k m1g is equal to the tension force. Now let's focus on the second block. So we need to focus on the forces in the y direction. So we have an upward tension force, a downward weight force, m2g. And so it's going to be the upward tension force minus the downward force. We're going to add a negative sign to that. And just like before, we're going to replace the net force in the y direction with m2ay, but negative m2ay, in order that this acceleration is positive to match this acceleration, which is going to be positive. So now let's take this term, move it to that side. And so we have m2g minus m2ay. That's equal to t. So now what we need to do next is we need to set these two equations equal to each other. So let me put this on top here. So we're going to say that m2g minus m2, I'm going to call this just a instead of ay, and that's equal to m1, let's call that a as well, plus mu k m1g. So every term that has an a in it, we want to put it on one side of the equation. So I'm going to take this term, move it to the right. And any other term that doesn't have an acceleration value, like this one, move it to the other side. So therefore, this is going to be m2g minus mu k m1g, and that's equal to m1a plus m2a. So now what we need to do at this point is factor out the acceleration. So it's m2g minus mu k m1g, and that's equal to a times m1 plus m2. So now we could divide both sides by m1 plus m2. So the acceleration is basically the weight force, that's the main driving force, minus the kinetic frictional force, which is mu k times m1g, divided by the total mass, which is the equation that we came up with earlier. Now let's go ahead and calculate the acceleration. So it's m2g, that's 8 times 9.8, minus mu k, which is 0.25, times m1, which is 12, and then times 9.8, divided by the total mass, which is 8 plus 12. 8 times 98, that's 78.4. 12 times 9.8, and then times 0.25, that's 29.4, and then divided by 20. So the acceleration in this problem is the same as the last problem. The acceleration is 2.45 meters per second squared, by coincidence. So now that we have the acceleration, we can now calculate the tension force. So let's go ahead and do that. So m1 is 12, the acceleration is 2.45, plus mu k times m1 times g. So 12 times 2.45, that's 29.4. And then this is also 29.4. So adding these two numbers, we can see that the tension force is going to be 58.8 newtons. So now let's make sense of these answers just like we did before. So I'm going to redraw the picture, just a lot bigger. So let's focus on the 12 kilogram block. So we have a tension force of 58.8 newtons that accelerates it to the right. And then if we calculate friction, it's going to be the weight force, which is 12 times 9.8, multiplied by mu k, which is 0.25. So that's 29.4 newtons. So to calculate the net force on this block, it's going to be the difference between the force that accelerates it to the right minus the force that decelerates it. So it's 58.8 minus 29.4, which is 29.4. And to confirm that answer, what you need to do is take the mass of the block and multiply it by the acceleration. Based on Newton's second law, that should give you the net force. So 12 times 2.45 does give you 29.4. Now let's focus on the 8 kilogram mass. So the weight force of that mass is 8 times 9.8, which is 78.4 newtons. Now the tension force in the x direction is the same as the tension force in the y direction because it's the same rope. So the upward force is 58.8 newtons. So if we subtract these two values, that's going to give us a downward net force of 19.6 newtons. Now keep in mind, this force should be negative because it's in the negative y direction. And the same should be true for that one too. Now, to confirm the net force, rather, we need to take this number and multiply it by the acceleration. So if you take 8 and multiply it by 2.45, that's going to be 19.6. So that's how you can tell if you have the right answers. It's a quick way to test and make sure.